Okay, now we're talking about dilations within the coordinate plane. So if I want to make this either shrink it down or make it bigger about a single point, um, I would have to first know what that point is. So let's just take the origin. This is going to be typical of many problems that you encounter. You want to dilate it about the origin. So let's double it. Right. So it's nice that it's at the origin because I could just multiply the point times 2. So this is negative 1, 6, so it's going to double, so it would be negative 2, 12. And I might go off the page here. I didn't really think about that. So this would be 6, and then actually you can think of it also as these little L brackets, right? So this L bracket would double and make it go up 6. So there's 4, 5, 6. So it would be way up here. And so I double that distance. And now doubling this distance, it's over 2 up 2. So go up another 2 and over 2. So 2, 2 becomes 4, 4. And then doubling this distance, which would be 5, 4, would now be 10, 8. So 5, 4, another 5 and 4 to go to 10, 8. So this is my new triangle. It's double the size. And if I wanted to dilate it by 1/2, I could cut everything in half. So this one was 1/6. Half of 6 would be 3. Half of 1 would be 1/2. So it would end up right there. 2, 2. Half of 2 is 1. Half of 2 is 1. So it would end up right there. And then this was 5, 4. So half of 4 would be 2. And half of 5 would be 2.5. Right there. So I end up with this shape right there. And you can see that it all would narrow down to this single point right here. You can see that each of the boundary lines go into that point. Alright, so that's dilating by 2 times and 1/2 about the origin, 0, 0. On this one, I'm going to dilate it 2 different ways. How about I'll pick 2 different points to cut it, to double it. So what if I doubled it about that point? So I just can draw my L shape. This is 3, 4, so doubling it would be another 3, 4 to there. This L shape is what I'm talking about. So this L shape goes 1, 5. Yeah, 1, 5. So I'll go another 1, 5 up to there. And this one goes 1, 4. We'll go another 1, 4 up to there. So I get this triangle like this that was double the size about point A. And if you drew a line going out from point A, you would see that that line goes directly, intersects at point A. Now, what if I doubled it about this point, point B? So this one, let's see, the L shape from point B, it's going down 5 over 6, so I'll go down another 5 over 6. And then this one, to that point, would go down 3 over 3. So another down 3 over 3. And then this point would be 3, 2. So another 3, 2. So in this case, my triangle looks something like this. It's doubled. And actually, because I doubled both of these triangles by the same amount, they should be congruent triangles because I'm just changing by the constant. But because I dilated them about different points, this one dilated that way, and this one dilated this way. So, and I could draw my lines going back to point B, just like I could with point A. And you can see that there. So that's kind of how dilations work in the coordinate plane. I use those little L brackets to say, okay, it's going to be double the size. If I wanted to scale something in half, then I have to count and cut each, the x coordinate and the y coordinate in half to break it down that way. Okay.